In this tutorial, I'm going to show you how to add a database to an already Dockerized Django project. So what we're going to be doing in this guide is I'm going to show you how to add a Postgres database to an existing Django project that's already set up and configured using Docker Compose. The technologies that we're going to be using are Postgres, Django, and Docker Compose. In order to take this tutorial, you're going to need the following. You're going to need Docker and Docker Compose installed and running on your machine. You can either do that by using Docker Desktop, which you can quite easily download and install, or you can use a tool that I like to use called Kalima, which allows you to also install it on a Mac OS or Linux machine. You'll also need the starting code, which is linked in the description of the video. That is the code that we're going to be working from this video. We also have separate tutorials on how to create that code if you're interested, which we will also link in the description. You're also, of course, going to need a code editor. I'm using Visual Studio Code. You can, of course, use whichever code editor you like to use. This tutorial is going to be broken down into the following sections. So we're going to start by adding the database service to Docker Compose. Then we're going to add the Postgres driver, the Python driver called psycopg2. I think that's how you pronounce it, or just psycopg. We're actually going to be using version 3 instead of version 2, which is the old version. And we're going to configure Django to use the database that's going to run in Docker Compose. And we're also going to be creating a simple core app in our Django project. That's where I like to keep all of the database code for my projects. We'll be adding a very basic database model to the Django project, and then we'll be logging in to the Django admin to test that the database is set up properly. Also, if you like this content and you want to support our channel, please, of course, like and subscribe. That's really helpful for us. And if you're interested in taking our more in-depth courses, you can find a list of them on our website, londonappdeveloper.com. We also have many more other free guides and tutorials on that website. So with that said, let's get started. So the first thing that we need to do is clone the starting code, which, as I said, is linked in the description. It's on GitHub here, so if you head over to that Django DRF backend project. Now this is the project that we created where we added a Django backend to a React project. It's essentially a project that has Django on the backend and a React front end, and it all uses Docker Compose to run the environments. Now, you don't need to follow the previous tutorials in order to do this tutorial. If you're just interested in how to set up Postgres, then you can just take it from the starting code. If you were interested in how we set up this existing project here, then you can take our other tutorials on how to Dockerize a React project and how to add a backend to a Dockerized React project. So I'm going to go ahead and click on this code icon here and copy the HTTPS URL. Then if you open up your terminal, or if you're on Windows, it will be PowerShell or Git Bash or Command Prompt, whichever one you like to use. I'm going to change to the directory where I like to keep my code, which is here in the workspace directory. And I'm going to type git clone, paste in the URL, and I'm going to call this Django Postgres DB. Okay, and then I'm going to change into that directory and I'm going to open it up in my code editor. Okay, so let's just quickly test this project and make sure that it works on our machine. So as I was saying, this is a Django and React project. So it has Django on the back end, React on the front end. All of the front end code is contained in the front end directory, and the Django project is contained in this back end directory here. We have two Docker files. So we have one specifically for the front end, which runs Node, and one for the back end, which runs Python. And we have a Docker Compose config that allows us to start and run our services. So this should already be set up and working. So if we go ahead and open up the terminal or the PowerShell window and just type Docker Compose up --watch, and then you hit enter, and you should get the server running here. So it might take a little bit longer for you because it will need to pull or build the Docker container or the Docker images, but mine's already cached here, so it started pretty quickly. So I'm going to open up my browser and just head over to localhost /8000/admin. This is the Django project. And then we also have the front end project running on 5173, which we're not going to really need for the purposes of this tutorial, but it's good to know that it's there running. So the Django project has currently been set up without any database. So if you open up the backend/settings.py, you can see that it just uses the default config that's created by Django, which has a SQLite database. So this will actually create a single file inside our Docker container or inside our running Docker container for the SQLite database. Usually when you're working with a real project, what you want to do is use Postgres or some other database service. So that's what we're going to be doing in this tutorial. Okay, so now that we have the service up and running, let's go ahead and follow the first step, which is to add the backend service to Docker Compose. So we're going to be adding our Postgres database as another service inside this docker compose.yaml file in the root of our project. So this is where we're going to make the first changes for our project. And what we're going to do is just at the bottom of the file here below backend, we're going to add a new service, and that is going to be called DB, short for database. Just make sure that the indentation is correct here. You should have 2 spaces between the start of the file or the start of the line and the name of the service here. It needs to be lined up with all the other services that we have here, like front end, back end, and DB. Okay, and now what we're going to do is we're going to add our image. So what I'll do from here is I'll just type it all out and then I'll explain after what each line does. So we're going to start with image : Postgres : 17.1, and then volumes : and then -db -data : /var/lib/postgres SQL /data. And then we will type ports : -5432 : 5432, environment : and then we're going to have a -postgres_db all caps equals db, and then postgres_user equals user, and then postgres_password equals local dev pw. And then we're going to type health check : test : and then in the square brackets here, we're going to have a list of things. So we're going to start with CMD. They're all going to be in double quotes. PG_is ready, and then -q, and then -d, and then db, and then -u, and then user. Now we're going to type interval : 5s, timeout : 5s, and retries : 5. Now at the bottom of the file, underneath this new service, we're going to add a new line right at the start of the file. So delete all of the spacing there and type volumes : and then db -data : Okay, now that's all typed out. Let's save the file and then I'll talk through it all. I should also mention that if you don't want to type this manually, then we also have the project and everything written in a blog post, which is also linked in the description of the video. So you could just copy and paste all of the code from this point onwards if you preferred that way. Okay, so here we have a new service called DB, short for database. And we're running the image Postgres 17.1. So that's the version of Postgres that we're going to be using for this tutorial. You can use more recent versions if there are more recent versions out by the time you're taking this tutorial. However, I recommend you use this version to start, and then at the end of the tutorial, you can try and upgrade. That way, all of the steps that you follow will be the same as the steps that I'm following here. So we're using this image, which is on the Docker Hub. It's available for free publicly. So Postgres version 17.1, that just allows you to run the database, the Postgres application in a Docker container. And then we have the volumes here. So the volumes are we're having a named volume, db-data, and we're mapping that to /var/lib/postgresql/data. So what this does is it makes sure that all of the data that we create in our database persists in this persistent volume called db data, which is mapped as or listed as a named volume at the bottom of the file here on line 40 and 41. So essentially what this means is when we stop the service, or we remove the service, or we restart our machine or something like that, then the data that we have in our database will be stored in this volume. So it will be persistent between runs of our container. And that's important because, of course, when you have data in the database, you don't want to lose that data when you stop the application or restart the application. So that's why we use this volume here. So this is the syntax on line 27. We have the name of the named volume, db data, that needs to match the named volume on line 41. And then we have the path inside the container where the Postgres data is going to be stored. So this is where Postgres stores the data. If you were using a different database service, for example, MySQL or MariaDB, then you may need to map a slightly different path here, but in principle, things should generally be the same. You can still run things in the Docker Compose service this way, just you might need to modify some of the specific Postgres lines that we have here. Okay, so that's the persistent volumes. And then we have the ports. So we're mapping port 5432, which is the default port for Postgres. We're mapping that to port 5432 on our local machine. Now, this isn't actually necessary for Django to connect to the service because it can do that using the private network inside Docker Compose. However, I do this just because it's useful, particularly for the local development environment, to be able to connect into that database using a tool like pgadmin or something so that you can access the data and have a look at what's going on in the database. So these lines here, the ports block is kind of optional, but I like to do it specifically for the local development Docker Compose configuration. Then we have the environment. So this is how we tell Postgres how to configure our database. So we're saying we want a database called DB. Now you could call this DB app, whatever. I recommend calling it DB for this tutorial. And this is the name of the database inside Postgres that will be created when this container starts. And then we have the user. So again, this is the user that will be created. We're having a user just called user, and the password. So I've got the password here, local dev PW. Now, of course, it's not best practice to hard code the password in the Docker Compose file, but it's okay for local development. Just you wouldn't want to deploy this to a real application that's running on a server somewhere using the hard coded name here. What you would do instead is you would use variables to set that as an environment variable that is not stored in with the code. So for this tutorial, we're just going to do it as our local development, so it's okay to hard code the password here. Then we have this health check block. So if any of you have followed any of our previous content, I used to use a method to check if the database was ready to accept connections by creating a custom Python script in Django. However, this is no longer necessary because we have this health check feature of Docker Compose, which allows us to run a command that will check the health of this service. So this is where we define this command here. So we have health check, and then we're defining the test, which is at what is this command that should be run to check whether the service is healthy. And we're passing in this command pg is ready, which is a pg is ready command that comes with Postgres. And then -q is the says run this quietly, which is needed for when you are running this in a script as opposed to running it manually, where you might want to see the output on the screen. We want to run this quietly, so it'll either return a success or fail to this command. -d is the database we want to test. So in this case, this DB here needs to match the database on line 31, or the name of the database on line 31. And then we have -u, which is the username that we want to use to test, which again should match the username we're using on line 32. And what this command does is it will allow Docker Compose to know whether this service is healthy or not. So this is really useful because what we'll be doing later is we'll be updating our app service so that it uses this health check to know whether it is okay to start the app, whether it knows that the database is ready. So we'll be going into that a little bit later in this tutorial. Here we just have the interval of the health check, the timeout, and the retries. So essentially it says, try this every 5 seconds. And then the timeout is how long do you wait until you assume it doesn't work. So again, 5 seconds, and then retries 5. So we'll try it 5 times, 5 seconds between each time. And if any request takes longer than 5 seconds, then we'll assume it's not working. Okay, so that's everything we need to do to set up the Postgres container. I'm just going to go ahead and commit this. So I'll do git add git commit -am, and I'm going to type added db service. Okay, so now that's done, let's move on to the next step, which is to configure our Django app to have the psycopg library, which is used as the Postgres driver, so that our Python application, or our Django application, which runs on Python, can connect to our Postgres service. So there's a couple of things we need to do here. We need to start by adding some dependencies to our Docker file for our Django project. So open up the Docker file, not dockerfile.frontend, just the Docker file in the root of the project. And we're going to make some changes here. So what we're going to do is we're going to add some libraries that are needed in order to install the psycopg library. So the psycopg library is the recommended Python driver. It's the most popular Python driver for Postgres, and it's what Django recommends you install in order to connect to a Postgres database. So we're going to be making some changes here. First, let's just restructure this a little bit. So I'm going to move lines 6 and 7, so this copy and work there, I'm going to move this below the run command here. So the reason I'm going to do this is just because I realized after I created this first container that it's actually a more efficient way of handling the Docker caches, because if you have the copy here, which is to copy the data or copy the files for our backend source code into the image that we're going to run our container from, then what happens is every time you change your code, it will then rerun all of the steps below that layer that was modified. So if we have the backend, copy backend to backend line above this run command, then it will rerun the run command every time we modify our code and rebuild our image. And we don't want to do that because the run command here is the bit that takes the longest in building our Docker image. So it's a minor efficiency thing. It just means that anytime you change your source code and need to rebuild your container, as long as you haven't changed any of the lines above this copy backend to backend line, then it should rebuild the image a lot faster on your machine. So it's just a minor improvement to our previous Docker file that we can make. Okay, next what we're going to do is we're going to change this line here. So we're going to add some more dependencies here. We got the Python m-venv to create our virtual environment. Actually, I also realized we don't need this here. So this was a error in the last one. So this env would actually create two virtual environments, one in the env directory and one in the /py directory. So we can remove env here because we only need our /py virtual environment. So we're always continuously improving all of the work that we do whenever we're creating programming. So this is a good example of that. Okay, so next what we're going to do is we are going to install some additional dependencies here. So we need to install them before we install the requirements here. So what I'm going to do is separate this requirements line onto a separate line, and I'm going to type run here. So we're going to install them separately, and then we are going to add another line here. So we'll do upgrade pip here, and we'll do ampersand, backslash, and then I'll do apk add --update --upgrade --no --cache Postgres ql-client, and then double ampersand backslash. And then we'll type apk add --update and then --upgrade --no cache --virtual then .tmp, and then backslash build -base and then Postgres ql-dev. And then on this line here where we install the requirements, we're going to do a double ampersand apk del.tmp. Okay, let's save the file and I'll just talk through some of the changes that we did here. So as I said, we moved this copy line below the run command just to speed up the building of our image. And then we modified the run command here so that it installs some additional libraries using the APK package manager that comes with Alpine. So we're using apk add, which is the command for adding a library to an Alpine image machine. --update says update the registry before doing this, just to make sure we have the latest version of everything. And then --upgrade says upgrade the registry if it needs upgrading. And then no cache says don't store any cache, because we don't want to store a cache inside the built Docker image because it makes it slightly larger than it needs to be. It's best practice to keep the footprint as small as possible when you're using Docker files, just to keep the files really small and make sure you don't have any additional files or things on there that could potentially be compromised by an attacker perhaps. And then we have the thing that we're installing, which is the Postgres QL client. So this client needs to be installed inside the running Docker container in order for psycopg to be able to connect to Postgres. So it uses this underlying libraries for this client here. So we're installing that, And we're going to install that and leave that on the machine. So we're not going to remove that at any point, and I'll explain that in a moment, because on the second line, we have the same command up to this point, except we are adding a virtual flag here. So what this means is set up a virtual group of, or a virtual set of dependencies that we can remove after we have used them. So what we do here is these are the dependencies listed on line 11 that we only need for the purpose of installing psycopg. We don't need these to be stored on the container after we have already installed psycopg. We just need them for the purposes of installing the psycopg package on the Docker image. So build base and PostgreSQL-dev are listed as dependencies that are needed for installing the psycopg package, which we're going to be installing in a bit. Then we are calling the install requirements line here. And after we install it, we have this double ampersand and then apk del temp. So this essentially, what this does is it will remove these dependencies listed on line 11 after we've installed the requirements.txt, which is going to contain our psycopg package in a moment. We haven't added it yet, but we're going to be adding it in a minute. So basically what that does is it just keeps the Docker image as lightweight as possible, because we're removing any dependencies that aren't needed for the runtime of our application. Okay, so now that's done, let's go ahead and open up the browser here, and we're going to select requirements.txt, and we're going to add a new dependency to this file. So we're going to add psycopg, and then in square brackets here, we're going to put C and then equals 3.2.3. Okay, and now let's just go ahead and build this, and I will explain what the C means there and why we do that in a moment. So Docker compose build, this is just going to test that the changes that we made are working and that there's no typos or errors in the code. Okay, it seemed to install correctly, so now I'll just go back and explain here why we put the C in the square brackets in the psycopg dependency here. So when you're installing this psycopg, you can install it in the binary mode, which most people do because that's the easiest mode to do it, and that means you don't need to have any of these additional dependencies here. All you need to do is install the binary and then it should go ahead and work. However, what a lot of people don't realize is that's only recommended for local development, which I appreciate. That is what we're going to be using this for here. However, I plan to eventually deploy this application to a server. So I want to make sure that the one deployed to the server is running on all the same libraries and the same packages as the one that's installed on my local machine. So I want the Docker image on my local machine to be as close as reasonably possible to the one that's going to be running on the deployed application. Now, there are some cases where you might need to change things or simplify things in the Docker file just for the local development. However, as a general practice, I like to, wherever possible, make sure it matches the production environment as much as possible, because that means any issues that you might run into on the production version, you're likely to encounter on your local machine, which gives you the opportunity to fix them early and prevent you from having outages and things like that when you deploy your application. So what we're doing here is we're following the recommendation on the psycopg documentation, which I will link in the resources of the video in case you're interested. And essentially it says you should use this C compiled version of the package when you are using this application in production. So that is why I put the C in the brackets here. And then we're pinning the version to 3.2.3 just to make sure that the version that you're running is going to be consistent with the version that I'm running in this tutorial. Okay, so now that we've done that, let's move on to configuring our Django project. So we're going to open up, or first I'm going to commit this change to Git. So git-am or git add dot git commit -am and then added psycopg. I appreciate I probably don't need the git add bit. It's just a force of habit for me to type that every time now. So it's easier for me just to do it than to remember not to do it. Next, what we're going to do is configure Django to use our Postgres database. What we need to do first is we need to make some changes to our settings.py file for our project. So let's open up the backend /settings.py. Now, if you ran the migrations already with the SQLite database, you might see the SQLite database here. You can just delete that because that's not needed for this project. So I'm going to delete it. If you don't have it there, then great. It won't appear there unless you actually run the database migrations on this project on your local machine. So since we don't need that, we will remove it and then we will make the changes that are needed. So the first thing we'll do is add a new import to the top here. Import OS, which is a module that's needed to retrieve environment variables that we're going to use to configure Django. So then we're going to scroll down to this database block here. So now it's line 80 to 85 since I've added the new line to the top. But essentially the databases block is where we configure the database that Django will use. So we don't need any of this. We can leave default because we're only going to define a default database, but we don't need this here. So we'll remove it and we are going to replace it with this. So I'll type it all out and then I'll explain what each line does after it's all been typed. So we'll type engine and then django.db.backends.postgresql, comma, and then name os.environ, actually not in quotes here, so we need name and then os.environ.get, and then in the brackets here db_name, and then user os.environ.get db_user, and then password is os.environ.get and then db_pass. I've got the comma here, and then a comma, and then host os.environ.get db_host, and then port is just going to be 5432. Okay, so save the file, and essentially what we're doing here is configuring Django to use the database. So these documentation variables or configuration variables are all documented in the Django official documentation. Essentially, the engine is the database engine we want to use. Django supports multiple different engines. You can use it with Postgres, MySQL, MariaDB. I think you can even use it with Microsoft SQL. There's many different databases that you can use with Django. And then you have the name, which is the name of the database inside the database server that we want to connect to. So we're going to be retrieving these variables using os.environ.get. And essentially what this does is it gets an environment variable that is configured. So we're going to configure an environment variable called dbName with our database name. And then when we run our Django app, that gets pulled in from the environment variables and set inside our settings.py file. This is how I like to configure Django apps. So then you only have one single point of configuration, and that is the environment variables of whatever is running the application. In our case, it will be Docker Compose. So then we specify the user, that is the username that's needed to connect into the database. Then we have the password, it's the password we need to connect to the database. And then the host, which is the host name, it's either the IP address or the domain name, the DNS name, fully qualified DNS name where the database is running. And then the port, I actually called this post here, so I realized I made an error here. This should be port. Good job to you if you spotted that before I did. Port is the default port that we're going to run our database server on. So 5432 is the Postgres default port. Okay, so save that file and then let's open up the Docker Compose configuration here so we can update our backend block to have these configuration variables that we just configured for our settings.py file. So what we need to do is first we're going to add a custom command. So below the volumes block here, we'll leave everything else the same here and then just add a new line that is kind of level with the volumes block. And we're going to type command : and then the greater than symbol. And then on a new line, I'm going to add an indentation here and type sh-c python manage.py migrate $ampersand. And then a new line here indented, we'll do Python manage.py run server 0.0.0.0.0:8000. I'll explain what that's for in a moment. For now, we'll just type the rest. So we'll type environment colon and then -db underscore host equals db, -db underscore name equals db, -db underscore user equals user, and then -db underscore pass equals local dev pw. And then we're going to type another block called depends underscore on colon, and this is going to depend on db colon with condition colon service underscore healthy. Okay, so save the file and then I'll explain what these changes are. So we started by modifying the command. So previously we just had the run server command that would run the server, or we actually didn't specify any command here. We just used the default command that is defined here, which is run server. Now, because we're adding a database, we need to run the migrations when we start the service. This makes sure that all of the changes that we made to our code and generated migrations for example, added a table, removed a table, added columns to a table, whatever you might be changing in your database, gets reflected in the actual running database. So that's what we do here is I have this command block. Now this syntax here is just, there's many different ways of running multiple lines on a Docker Compose configuration. I prefer this approach where you have this greater than symbol, and then below that you have the command indented, and I group the command in this sh-c, which means run this shell command. And I like to separate them by ampersands and put them on separate lines just to make them easier to read. There's nothing worse than a hugely long command that you need horizontal scrolling in order to be able to read what it says. We have the migrate command here, which will run every time we start our service, and then the run server command. Then we specify our environment block. So db host should match the service name that our database is running on. In this case, it's just db. So that matches the service name defined on line 35 here. And then we have db name that should match the database name configured on line 42. That's the name of the database that's running inside Postgres. Then we have the user. Again, that should match the line on 43. So you want to make sure the username is that Django's using is the same username that's connected or configured in the database service. Then you have the db pass, which, as you might have guessed, should match the database password that is configured for our Postgres service. So that's all the configuration variables. These, as I mentioned before, will get passed into this block here in our settings.py file when we start our Django app. So it gets passed in using this here. We'll get the value of db name, which will be set here, and so on. Okay, then we have this depends on block. So depends on allows you to set up dependencies between services. So we're telling Docker Compose that our backend service here depends on the database service. It depends on the DB service. So in other words, the backend service can't run until the database service is running. And we're taking that a step further by adding this condition service healthy. So we don't just want the database to be running, but we want it to be returning healthy from this health check here. So that's the syntax in Docker Compose for ensuring that this health check is passing. And the reason we do that is because there's this issue called a race condition where if you start both your services at the same time, so if you start your DB service and then you start your backend service either at the same time or shortly after, then what can happen is the database service may have started. However, the database, that is the application running in that service, might not be ready yet to accept connections because there's a slight delay on the setup while Postgres sets up the database initially and sets things like this username and password and stuff. So what you could get is you get an issue where you try and start your service and then the Django app crashes because it tries to connect to the database too quickly and the database isn't ready to accept connections yet. So it rejects the connection and then Django fails. So this can happen intermittently. It can be very annoying. It could also not happen. So you might test this and it might not work, or it might work as expected. However, it definitely does happen intermittently. So the way around this is you define this health check here to make sure the database is running, the service is started, and the database inside that service is actually running and ready to accept the connections. So that's why we do that. Now let's go ahead, make sure you save the file, and we'll go and commit this to Git. So git commit am added configured Django for DB. Okay, so now that's done, let's go ahead and create the core app for our Django project. So I like to group all of my database code inside an app called core in a Django project. It is optional, you don't have to do it that way. Other people have different preferences. It really comes down to personal preference, but I do think there are some benefits to it. For example, it keeps all of your underlying database code, which typically is used by the other apps in your Django project, in one place. So you don't have to worry about the dependencies between different apps that you might have. You know that if there's a database model, it's always going to be defined in your core app. Also, if you ever wanted to split up your Django app into microservices or something like that, then you could quite easily abstract your core app outside of the other apps so that you have your core app, which is the consistent code that all of the services need, separate from the individual apps that you might create in your Django project. So really it just comes down to personal preference. I appreciate not all projects, in fact, probably most projects will never need to be split up into microservices. That's really just a thing for like scaling at massive organizations. However, I like to set it up like that anyway, just because it's a nice clean structure and it's easy to understand. Okay, so we'll create our app and we'll run the command through Docker Compose. So I'll type Docker Compose run --rm, and then the name of the service, backend, and then --sh-c python manage.py start app core, and then close the double quotes here, hit enter. And because we haven't run our service so far, it's going to need to pull the database down from Docker Hub. So we're going to just wait for that to finish and then we'll continue. Okay, so you can see that there wasn't really any output here, except if you look in your project, you should see a new app called Core created in our Django project. So this is the app that we wanted to add. It automatically adds these files. We're going to leave that as it is for now, and we're just going to open up our settings.py file from backend /backend /settings.py. And we're going to add this new Core app to our list of installed apps in our configuration here. And then we'll save the file and I'll open up terminal and I'll commit the changes. Added core app. Okay, now that's done, we're ready to move on to the next step, which is to create an actual model that we can use for testing. So let's open up our project code and we're going to open up backend /core/models. And we're going to add a new model here, and it's just going to be a simple model, and we're going to call it recipe. So I'm going to delete this comment that they add here automatically, and I'm going to type class recipe, and then open the brackets here, models.model. And I should say that if you're worried about this underline, this is just because I don't have the Python virtual environment set up on my local machine. Because all of the Python dependencies are isolated inside Docker, Visual Studio Code doesn't have the ability to use the IntelliSense functionality in order to connect to it. So if you want to be able to do that, you actually need to open up your terminal and simply just type python mvm. This of course assumes that you have Python installed and set up on your machine. So I'm just going to type that, and then you can type, you can hit yes here because that picks up that virtual environment for Visual Studio Code. I'm going to do source env/bin/activate pip install -r and install the requirements.txt file here. And the only reason why we need to do this is because if you want to get the IntelliSense functionality, then your Visual Studio Code needs some way of accessing a Python interpreter that has the Python dependencies that you're referencing here. There's different ways of doing that. You can integrate Visual Studio Code with Docker, however, I find that quite messy and I don't like that approach. I've never made it work reliably. So I just install a virtual environment on my local machine and install it. Okay, so with that aside, let's go ahead and continue. So I've got the recipe model here, or class. So I'll finish typing this and then we'll explain what it does. So I'll just add a quick comment here. Represents a recipe in the system. And then name equals models.char field. Max length equals 255, and then steps equals models.text field. And then we'll do def __str __ self return self.name. Okay, and then save the file. So essentially what this does is it creates a new model, a new database model in Django. So the way Django works with its ORM, or Object Relational Mapping System, is it allows you to define tables for your database as these models here. So we define them as a class that inherits from models.model, and then we specify the fields as the attributes of that class. So here we have the name variable, which is the models.char field, and that sets up a character field with a max length of 255. And then we have the steps, which sets up a text field. So essentially you create your different database tables inside your models in Django, and then Django handles setting that up in the database. The str here is just, or the block on line 9 and 10 is just the string representation. So that means when we convert an instance of this recipe model into text, what field should it show? We're just going to show the name by doing self.name. Okay, so now that's saved, what you need to do is create a migration. So the way Django works is you define all of your models as per how you want your database to look, and then you can create what's called a migration file, which tells Django how to set up the database tables to match the models that you have. So every time you make changes to your models in a Django project, that is either you modify a field, you add a new model, you add a new field to a model, or anything you change, you need to recreate your migrations so that Django knows what changes to make in the underlying database software. And this is how Django works with so many different database technologies, because it has support for all of these different database backends. You essentially can run different database technologies using the same models, but you don't need to worry about the specific code for creating tables in that database. Okay, so once you've added that, you need to save the file and then open up terminal and type docker compose run --rm backend and then sh-c python manage.py make migrations, and then hit enter. You can see here it said it's created a new model recipe. So we're going to open that up and take a look. Now this is the auto-generated Python code. You don't need to change this, but it essentially tells Django how to make changes to the database. Okay, once that's done, you can go ahead and stop the service if it's running by doing Control-C, and then we'll do docker compose build just to make sure we've built in all of the changes, and then we'll do docker compose up --watch to start our database service. Okay, so I missed one step, so even though this is running, the next thing we want to do is set up our Django admin. So if you open up admin.py, you can go ahead and type admin.site.register here, and then we just need to also import from core, import models. So we're going to register our model, models.recipe. So what this does is it tells the Django admin that we want to be able to access the recipe model inside our Django admin. Okay, so now that it's running, it should auto reload. If it didn't auto reload after you made that admin change, then just stop the server and start it again. But now we're actually ready to test. So we'll move on to the final step, which is to test our new database in the Django admin. So make sure the server is running, and then in a separate tab or a separate window of your terminal, we're going to type docker compose run --rm backend sh-c python manage.py create super user. This is going to create a new user that we can use to log in. So I'm going to put just a sample name and email address here, and then a quick password. And then this allows us to open up the browser. And if you head over to localhost port 8000/admin, you don't need this login bit here, it should auto add. You can log in with the credentials that we just added. So here we have our Django admin. You can see our recipe models here. So if you click on that, you can go ahead and add a recipe, test recipe, and then step 1, so on. Okay, so that's all set up, and it's now successfully saving things into our Postgres database. If you like this video, please let us know in the comments, or if you have any suggestions of future videos that you would like us to create, then please also put them in the comments, and we can go ahead and take that feedback and try and make content that you're interested to see. Thank you so much for watching, and I'll see you next time.